Okay, so 92 on 267. This is the cost function. Find the marginal cost function. So C prime equals 2 minus 0.04x plus 0.00021x squared. We agree? Part B. Find C prime of 100 and explain its meaning. C prime of 100. C prime of 100 will be 2. If I multiply this by 100, I get minus 4. If I can't multiply this by 4 zeros, 1, 2, 3, 4, I get plus 2.1. And I get 0.1. Am I correct? Let me know if you got something else. Am I okay with 0.1? I need measurement unit.
It's dollars per commodity.
Perfect. Excellent. Explain its meaning. We have the meaning in the handout that we filled out yesterday.
It's telling you how much the first unit will cost.
Right. It predicts, yes, it gives the rate of change of the cost at production level of 100, but it really predicts the cost of 101st item. Okay, perfect. That was B. Part C. Compare C prime of 100, which we have already in part B, with the cost of producing the 101st item. So first I have to determine the cost for producing the 101st item in order to compare it to 0.1. How do I get the cost of producing the 101st item? What do I have to do? Remember, it's delta y. That's what it is. Your delta y is one thing, right? Which is f of x plus delta x minus f of x. This is what I'm trying to do. I'm trying to determine delta y. This is dy. It's c prime of 100 times 1. dx is 1. That's why. This is the cost given by dy. This will be the cost given by delta y. And we know that delta y and dy are close to each other from that figure from last week. Okay, so f of x plus dx, how much is dx and how much is x? X is, of course, 100. That's what we are talking about, right? And delta x is, of course, is what? 1. 1. So that's why this is 101. So I have the cost of 101 minus the cost of, that's it. So please plug in 101 in the original function and plug in 100 and tell me what you get. We have to plug it in the calculator. I recommend that. So go to y equals and put in 920 plus, no, it's, yes, plus 2x, and then minus 0.02x squared, and plus 4 zeros, 7 x cubed. And then go to second and table. Of course, yes, I have to, I know. Okay, it won't let me do it. I'm not sure why.
I thought you needed to be able to change the input when you started out.
No, it just doesn't allow me to go to second and table set.
Maybe refresh it. See, it has that loading symbol in the bottom bathroom.
The whole thing disappeared now. Okay. Okay, never mind. So what is it?
0.1
Point. Measurement unit.
dollars per unit.
And now I'm asking you this. Do you prefer determining C prime of 100, which is basically delta y because dx is 1, or you prefer doing this to get the exact cost? And look at them.
Or they do delta.
Right. Exactly. This is not convenient. This is convenient. Good. Let's take a look at something else.
Can we do
Yes?
differential?
Say it again.
Can we do implicit differential?
Yes. Yes. Implicit differentiation. I let you choose. Let's go back and choose implicit differentiation. On page 215, choose anything you want from 5 through 32, or 35 to 38. 5 to 32 or 35 to 38, page 215.
Do 17.
Yes, 17. I think we did 17, but let's do it again.
Well, if we did it again, I just go back.
That's no, I'm not so sure. It looks familiar, but I can't be certain. So 17 on page 215. I'd rather do it than you look for it and not finding it. Okay, can I remove my tent? I think I can. Okay, good. Much better. Okay, so then suggestions here. Well, of course, the left-hand side and the right-hand side. The left-hand side, how do I differentiate the inverse of tangent? It's on our review sheet. 1 over 1 plus, in this case, x to the 4th y squared times. Perfect.
What is 1 plus x to the 4th y squared?
Look at the handout. You have the handout with the formula.
Okay.
Better?
Yeah.
I can still explain.
Oh,
That
no,
doesn't, that does not, they're not mutually exclusive. If you look at the formula, it doesn't mean that I don't have to explain.
It's 1 over an x squared, so you plug in
Exactly. In
function
x squared.
x squared.
Yes. Good. Next step. Times the inner function prime.
So that's 2x.
Yes, times y plus x squared times. Excellent. And now the right-hand side.
1 plus 2y dx.
1 plus x prime is 1. So y squared plus x times 2 times y times dy over dx. This is function 1 and this is function 2. The first function prime is 1 times the second function plus the first function times the second function prime. 2y dy over dx. Better? Yes? Agreed?
Do we have to put the dy dx?
You want to put y prime instead of it?
I was just asking, like, do we have to put those in there? Say if we know mentally, like, that we're doing the deriving, we're doing the differentiation right there. We need to put that less in the
But if you don't write this, how will you know to solve for it?
oh,
Because you have to solve for it. And you cannot, no one can do this mentally. I can't. I mean, I have to distribute this to these two terms. I have to move this term to the other side. I have to move these two to the left. factor out dy over dx. I can't do this mentally. So now I distribute this to these two terms. So I have 2xy over 1 plus x to the fourth y squared plus x squared over 1 plus x to the fourth y squared dy over dx equals 1 plus y squared plus 2xy times dy over dx. For now, I just cleaned it up a little bit. Now, this and this have to be on one side. These two have to go to the other. So then the left-hand side becomes 2xy over 1 plus x to the fourth y squared minus 1 minus y squared. And when I move this to the other side, I factor out, I have x squared over 1 plus x to the fourth y squared dy over dx. That's what makes it hard, implicit differentiation, because it involves a lot of algebra, right? Distributing, maybe sometimes factoring, like here, for example, I had to factor dy over dx. Tony, are you okay with this? So final step, dy over dx. It's not really final, like I could simplify it a little bit. So what is the final step so far? I have to write this at the top. 2xy over 1 plus x to the fourth y squared minus 1 minus y squared. And I have to write 2xy minus x squared over 1 plus x to the fourth y squared. This rings a bell, and I think we did this problem, but maybe not. I can simplify multiplying both sides, the top and bottom, by this and eliminate it. So dy over dx is 2xy minus, when I multiply negative 1 by these, I get negative 1 minus x to the fourth y squared. And when I multiply by y squared, I get minus y squared minus x to the fourth y to the fourth. Same thing here. 2xy plus 2x to the fifth y to the third minus x squared. Just because I wanted to eliminate the denominator. But I had to multiply both the numerator and the denominator by this quantity. So I multiplied here, and I got 2xy. I multiplied this by this, and I got these two. And I multiplied negative y squared by this, and I got these two. Here I only had one term, so I only needed to multiply this by 1 and this by this to get this, and minus x squared. Anything else that you can think of? Other types of problems? Yes. Yes. Ian?
So it was more so I needed help on the simplifying.
Yes?
The problem, it was on section 3.3,
Yes?
number 13.
13 in 3.3. Let's take a look. 3.3. Number 13. Okay, so y equals cosine x over 1 minus sine x. Perfect.
Sorry.
Maybe.
It should be y equals t sine t over 1 plus t.
Oh, of course, because I copied 12 instead of 13. course. So t sine t divided by 1 plus t. Very good. Good. Sorry about that. So y prime, this is function 1 and this is function 2. However, function 1 is the product. So I need to differentiate the product. Then I will multiply by 1 plus t minus the numerator times the denominator prime, which is 1 over 1 plus t squared. So far, so good? So the first function prime will be here. It's waiting for a second. Times the second function minus the first function times the second function prime, which is 1, over the function in the denominator squared. Okay. The first function prime, this is now number 1 and number 2. T prime is 1 times sine t plus t times sine t prime, which is cosine t. Is this okay? It will be terrible to do this, to simplify this with this. It will be a terrible mistake. We cannot simplify anything but factors. So now I will distribute, because it's possible that I can cancel some terms. So I will distribute 1 to these two, sine t plus t cosine t, and then t to these two, plus t sine t plus t squared cosine t, and then minus t sine t over 1 plus t squared. And yes, these two go away. There is nothing else I can do. So I have sine t plus t cosine t plus t squared cosine t over 1 plus t everything squared. Any questions on this? Is this okay? Okay. Do you have anything else that you worked on? Anyone? Anything else that you worked on that you want to go back to? Let's work on some limits. On page 198, 39 through 48. 39 through 48. Please choose. Any preference?
Let's do,
30?
Oh, I'm sorry. Um, 47.
47. Perfect. So we have limit. At the top, 1 minus tangent x. The denominator sine x minus cosine x. And as t approaches pi over 4. Not x. Not t. X, sorry. Pi over 4 from either side. Perfect. What is the first thing I need to do when I calculate a limit?
Plug in.
Yes. So what do we have at the top when I plug in pi over 4?
1 or 0.
Very good. What do I have at the bottom? This is the only angle for which sine and cosine are the same.
0.
Yes. So the easiest thing to do is apply something we learned, which is, if it's applicable, L'Hopital's rule. So then, limit Sx approaches pi over 4. What is the top?
Minus secant squared x.
Excellent. What is the bottom?
Cosine
So this is cosine, and you're right. You're right, because this is prime sine with negative in front and another negative. Excellent. Very good. Excellent. Good. Okay.
What's on the way that allows us to directly take the derivative of the
Only
top?
in a limit.
Only in a limit, okay.
Never for a function. Only inside the limit, and only if you have 0 over 0 or infinity over infinity.
You take the derivative of the top. and
So
the
never
bottom.
do it for functions.
Okay.
You can do it only for a limit and only in these two situations. Okay, let's plug in. Have to do that. I don't know what it is. So what is the numerator? How much? If you're plugging the calculator in your if your calculator is in degrees and you're plugging in radians, then you won't get anything that is worth anything. Yes? I need the answer for secant squared pi over 4. Yes, with minus in front is indeed -2. Perfect. What about the denominator? What is cosine or sine of pi over 4 equal to? We don't want a decimal. It's the only angle for which sine and cosine are the same. What is the number?
Whatever you choose.
Thank you. So the square root of 2 over 2 plus the square root of 2 over 2. The numerator is -2, and the denominator is, so it's the square root of 2 plus the square root of 2 is 2 the square root of 2, and you simplify. So now I have -2 over the square root of 2, and I need to rationalize it. So it's negative the square root of 2. L'Hopital's rule is very useful in these situations. Very useful. Very good.
How do you change the calculator from degrees to radians?
Go to mode,
Got it. Oh, okay.
and you change it. So this thing is so frozen that I cannot even get out of it.
Task manager.
Yeah, right click on the taskbar. Then it should give you the option for a task manager.
On here,
No, on anyone in the taskbar. Like in the empty space on the taskbar, right click.
I'll scroll down. Good. Not scroll down, but
Move your mouse down to the taskbar.
the cursor. Yeah, the cursor.
yeah, I'm doing it. It's not doing
No,
anything.
bring your mouse down to the taskbar.
The black bar at the bottom of the screen, and then just like find an open space, and then right click, and then task manager,
Got it.
and then just go to the TI smart view, and then I think right click, and then pick the process. It's at the
Move
top.
at the top. Move at the top.
Was it at the top?
Yes.
It's an application.
First thing, like very first.
Perfect. Thank you. Excellent.
I'll let you know.
Okay. So right here, go to mode, and from radian to degrees, or
Got it.
degrees. Okay, good.
Okay, thank you.
Thank you. Good. Any questions? Is there anything else that you would like to go back to? Anything else? Yes. Let's also look at 46, just to see how useful this L'Hopital's rule is. We couldn't have done it sooner. And it's not in this chapter, it's in chapter 4, but it's so useful that I can't wait to chapter 4.
I have a question about that.
Yeah.
So on the final, when we're looking at limits, maybe for the chapter 2
You can use any method you like.
Okay,
I'm
now
not
that we know that.
the only yes, but the only thing that that you have to do is, for example, if I ask you to find the domain of the function first, you have to find it. L'Hopital's rule doesn't work in all situations. So if I'm asking you, for example, to simplify a function with absolute value first, you have to do it. Yeah. So what is this? Does it equal to? Right. So then limit as x approaches 0. What is the denominator?
One.
And the numerator?
Cosine.
Sine prime is? Yes. Cosine x squared times? Times the inner function prime. 2x. Good, so let's plug in 0 again. Where does this go? Cosine 0 is how much? I just didn't hear. I'm not saying 1 indeed. Perfect. So if this goes to 1 and 2 is 2 and x goes to what? Good. So I have 1 times 2 times 0 over 1. What is the answer? 1 is in the denominator. You cannot make 1 into a 0 in the denominator. It's 1. You can't change that into 0 to make it undefined.
The top is 0.
Right. If the top is 0 is 0.
So just 0.
That's it. 0 is allowed at the top. 0 is not allowed in the denominator. If I have $0 and I choose 2 of you to share my 0 with, how much will I give you?
Nothing.
Nothing. So 0 can be divided by anything except 0. But we cannot divide by 0. Good. Anything else you would like to go back to? You can start tomorrow from 4:30. My pre-calculus starts. They want to start early at 4:30 with some questions. You can come from as early as you want.